Welcome back to Atomic Math. Today we're going to look at factoring, and factoring is one of the most important algebra skills you can have, especially if you take calculus. So let's take a quick look at some ways to factor polynomials. So, greatest common factor. This one's common for sort of simple equations where you have something you can easily divide out of all of the terms. So in this case, if you look at this example, all of those terms can be divided by both 5 and x squared. So if we do that, if we take out a 5x squared, we get x squared minus 7x plus 2. Another method that we can use is grouping. So let's look at grouping. So if you have an example like this, we don't have a common value that we can just take out of everything except for x. So first we'll do that. We'll factor out x. But we're still left with quite a bit. And there's nothing that I can take out of all four things. But if I look at the 10ab and the 15b, they both share a factor of 5b. And if I look at the minus 8a and the 12, they both have a factor of 4. So let's create a common term. So if we have 10ab plus 15b and then minus 8a minus 12, we can factor out a 5b out of the first term and a minus 4 to the second term. Now you notice by doing that, I'm creating two terms that are the same. And that's the whole goal. This doesn't work if you can't create two terms that are the same. So this method only works in special cases. It's likely to not work most of the time, but it only works, like I said, if you can make these common numbers, because what you're going to do is you're going to make that one of your factors, and then you're going to take the outside terms and make them the second. So the 5b minus 4. So now we have x on the outside times 2a plus 3 times 5b minus 4. And of course we can take out those square brackets and get us to here. So again, this is kind of a very sort of unique method that only works in sort of special cases. So let's look at quadratics, everybody's favorite. So a quadratic is an equation of the form like this: ax squared plus bx plus c. So let's look at an actual example. In this example, we have a equals 1, b equals minus 5, and c equals 6. So if we want to divide this into two factors, we need to figure out this question. And that is, what can we do x plus something times x plus something? So we have to figure out what m and n will be. So how do we find those? Well, first we're going to say that, well, we know that m plus n has to equal b. And we know that m times n has to equal c. So in our example above, that means that m plus n has to equal minus 5, and m times n has to equal 6. So based on that, we're going to try m equals minus 2 and n equals minus 3. And this shows how I got to that. So we try x minus 2, x minus 3, and that gives us x equals 3 or x equals 2. Now, sometimes they're not nice, easy numbers like this, and that's where we use the quadratic, which I'm sure most people have nightmares about. So let's look at the same example, but using the quadratic formula. So in this example, I've filled everything in for a, b, and c. And basically I get down to this, and you can see that ultimately I get two options, x equals 3 or x equals 2, which is the same as I got the other method, but this is helpful when you don't have something obvious or you can't split it up easily. The other way of factoring is identities. Recognizing certain forms and using identities is very important. So let's look at the first one, the difference of squares. So if you have something x squared minus y squared, you have to recognize that that can be factored into x minus y multiplied by x plus y. If we look at the sum of cubes, same thing. So x cubed plus y cubed is going to equal x plus y times x squared minus xy plus y squared. So if you get your equations into some forms like this, then you can make them just simple x cubed plus y cubed. The difference of cubes, similar, slightly different. The first term is going to have a minus in it. So I want to point out, when I mentioned, let's look at the first one, the difference of squares. X squared minus y squared. It's not always going to look like that. It might look like this, x squared minus 9. You need to recognize that 9 is 3 squared, okay? Another example that people don't always see is this, x squared minus 1. You need to recognize that that is x squared minus 1 squared, because 1 squared is 1. So really the term is, you have to think of it like this. So there are two more helpful identities, and we have basically the square of a sum. And so this is going to equal x squared plus 2xy plus y squared. And of course, the square of a difference. Same thing, only one of the terms is now negative. So knowing these when you're trying to factor things is very helpful. It's sort of the trick a lot of times, and when you can't figure out how to factor something, you'll realize someone will show you and it's one of these identities. So let's take a look at completing the square. So this uses the identities. So we're going to look at one of the two examples that I showed you at the end, the x plus y squared and the x minus y squared. Now I'm just going to use the x plus y for an example, but they're both the same. So let's look at this equation here, x squared plus 4x minus 5. So basically, in order to get this into the right-hand side of the equation above it, I kind of need 4x to become this 2xy. So basically, I have to have a 2x, and then I need a y. So the only way I could do that is maybe by making y equal 2, and then 2 times x times 2 would give me 4x. I also need to try and turn y squared into minus 5, which is not as easy, but we will look at that in a second. So basically, if we set y equals 2, we know now that if our last term is y squared, then that should be a 4, not a minus 5. So we have to figure out how do we get there. So if we were going to do the square, we would want something like 2 squared minus 9. That equals minus 5. So basically, we're trying to figure out a way to make 2 squared equal minus 5. And the only way to do that is to add a minus 9. Okay? So it still equals minus 5. We're not changing anything. We're just writing it differently. Okay, so we'll set our equation to 0, and we will plug those numbers in. So you can see here I have 2x times 2, that's my 4x, and I have my 2 squared minus 9, that's my minus 5 from my original equation. Okay, but I only want this piece because that's what's going to give me the ability to complete the square. So I need to get rid of this 9. So let's add 9 to both sides, and now we have our equation on the right side, on the left side, sorry, and 9 on the other side. So we know that we can write this now as x plus 2 squared, and then 9 can be written as 3 squared. So if we take the square root of both sides, then we are going to get x plus 2 equals 3, which of course then gives us x equals 1. So this is a common one I see. You have to remember that you can do things to equations like adding numbers as long as you're not changing the overall value. So minus 5 can easily be written as 2 squared minus 9. It equals 5. But sometimes you don't see the pattern. Being able to recognize the patterns and know that that's what you should be looking for, that's the trick. And so coming up, I'm going to do a video on many examples, common ones to sort of chemistry and physics, and we'll actually get to see how these are all used, but we'll also see the thought process and how to identify which method am I supposed to be using here. So if you are ready to stop struggling and you want to learn more, go ahead and hit the subscribe button and keep an eye out for my next video, which will be the math lab, and it will be on all the stuff that we've been practicing. Well, it will be practice for all the things that we've been learning.